Hey there, everyone. My name is Laksha Kumar, and I'm a high schooler, goes to Montevis High School, and I'm excited to show you guys my new project um, for the hackathon. So I built ClassifyGenius, which is a interactive machine learning application using Streamlit, which is an open source framework used to build machine learning web apps. So that should kind of give a hint of what I built. It's the application that I built is a simple machine learning application that lets you explore different classifier algorithms and lets you use those algorithms to classify these data sets, right? Like these following data sets: iris, breast cancer, and wine. And so before I get into the application, why don't we just take a quick look at this code over here? Um, so yeah, I did this in Python. This was my first time using Streamlit. So it's a Python framework, as I said. So first time, so I was doing a few tutorials on that, learning here and there and stuff. So that went pretty nice. So I used Streamlit, and then I used NumPy, and I used Matplotlib for the plots that I did for the classifications of the data sets. And then I also used another machine learning library called scikit-learn, scikit-learn. Basically, it just gives tasks to the models, right? Using these libraries, so I had to learn the methods for that. So let's get into it. But yeah, before we get into it, here's just here's the code here. Here's classifier, the functions for that. Then for the plots, and then here's just like a few things to improve on in the future. So why don't we go back? All right. So as said, this application that I built, it's a simple machine learning application that lets you classify different data sets. So with these following machine learning algorithms, pretty popular. So first we have the k-nearest neighbor, KNN. And then we have the SVM algorithm. It's for vector machines. And then we have the random forest algorithm for the trees for the decisions in classification. All right. So along with this, let's look at the iris data set here using the KNN classifier. Here we can update the parameters for the classifier with the scroll bar here, and with that you can also get like a whole view, right, of your data set over here. So you get the shape of the data set, the number of classes, right, the dimensions, and you also get an accuracy, which is really, really important for the plots and just knowing the accuracy of the model itself. So here is the plot, and you can adjust the accuracy with different parameters here in the scroll bar. So here we have a perfect accuracy of 1. Let's say if we go to 0, it goes down a little, right? So that's how the accuracy changes. So that's one accessibility that I wanted to add when simulating these models. Now, it's fairly easy to get a perfect accuracy, but now why don't we check some of the different sets with the different classifiers. Let's look at the breast cancer set. Again, right, we have the whole overview, right, of data set. We get our accuracy, and here maybe we could use SVM. All right, with SVM, here we can see our accuracy is continuously changing, right? So, right, with different classifiers, you can see here. So, again, if we also use the random forest one, it is going to be a little more complex with the classifier, with the sorry, with parameters, right? So we have the max step parameter, and then we have the estimation, right? So again, we can still change the accuracy up a little here and there. Um, Now, let's say if we wanted to see like which parameters are the best, which we did, but the last thing we can also see with this is also the plots, right? So why don't we switch back here to iris? We can see that the plot changes as the accuracy and the shape of the data set also does change. So it does change for each different data set, right? And with each principal components, and it would also be changing with the classifiers. But with these separate sets, we see that that with having the plot working, these four dimensions here in the shape of the data set only gets transformed into two principal components. That is for each of the data sets and their accuracy. And if we also, let's say if we select a different one, right, like the wine set, um, and yeah, so we see here, yeah, it is working, and we do have different, what do you call it? We have different different parameters that we can use to change up the accuracy, which models the plot for the set. So yeah, here we have a nice little interactive machine learning web app. This was again my first time using this, so learned a lot of new things, and I'm grateful for what I learned with this. And it's a long way from here because I'm going to be adding some more stuff. But yeah, this was my project for this hackathon, Classify Genius, and I appreciate you for